Hello friends, welcome back to our channel. So in today's session we'll see an example of solving higher order recurrence relation. So in our previous session we have seen the complete formulas for solving higher order homogeneous recurrence relation. Now we'll see an example. So without delay we'll start. So higher order homogeneous recurrence relation. So we'll take one example and we'll solve. So whatever, if the current term depends upon more than two previous terms, then we call it as a higher order homogeneous recurrence relations. So this can be either third order, fourth order, fifth order, and so on, right? So first we have to find which order the given recurrence relation is, and that many roots will be there. So first we have to convert into auxiliary equation, then we have to find out the roots, and based upon the roots we have to give the general solution. So let's take one example and solve that one, right? So let us take this example: an minus 6an minus 1 plus 12an minus 2 minus 8an minus 3. So first we need to find the order. So in order to find the order, what is the formula? So highest subscript minus lowest subscript. So from this, the highest subscript is n minus lowest subscript is n minus 3. So which is n minus n plus 3, which is equal to 3. So the given recurrence relation is of third order. So the number of roots is equal to 3, k1, k2, k3. So first we need to find these three roots because this is a third order. So we'll be having three roots, right? So first let us convert this into auxiliary equation. So how it is converted into auxiliary equation? See, an is equal to k3 because this is a third order, right? And an minus 1 is equal to k square. An minus 2 is equal to k power 1 and an minus 3 is equal to k power 0. So 1, right? So that will be k cube minus 6k square plus 12k minus 8k power 0 is 1. So it is 0. So this is the auxiliary equation. Now we need to find out the roots. How many roots? 3 roots. So because it is a cubical equation, it's not a quadratic equation. If it is a quadratic equation, directly we can find the roots by using the formula minus b plus or minus square root of b square minus 4ac by 4a. So by using that formula, we can directly find the roots. But here it is a cubical equation. That means it will be having 3 roots. Now, what is the procedure to find the 3 roots? So first we can convert. We have to find one root, and then we can convert into quadratic equation. How it's done? So this finding of roots in a cubic equation is synthetic method. Synthetic division method. So by using this synthetic division method, so we can find the roots of a cubical equation, right? So now let us see. So most of you know about this synthetic method, or if you don't know, no problem, I'll explain everything. Okay, now the synthetic method. First take the coefficients from this particular cubic equation. What's the first coefficient? 1. Second one, it's a minus 6. Third, it's a plus 12. Fourth, it is a minus 8. Okay, so these are the coefficients. So we have to start, we need to use some trial and error method to find the root. So if you go with 1, okay, let us consider 1 is a root. So initially make it as 0 and add these two terms. Make sure. So this part is a trial and error method. This is one root. Okay, when we can say that is the root of this particular cubic equation means start with 0. Okay, first one, initialize it to 0 and perform the addition. So it becomes 1. So 1 into 1, it is 1. So write it here. 1 into 1, 1. Minus 6 plus 1, minus 5. So 1 into minus 5, it is minus 5. So 12 minus 5, it is 7. So 1 into 7, it is 7. What's the result here? It is minus 1. So if you proceed with this particular procedure, okay, if you follow this particular procedure, we have to get this part or this column as 0. If you got this column as 0, then definitely you can say this is a one root of cubical equation. So here in this case we got a minus 1, it's not a 0, we got a minus 1 in this place. So we can strongly say that this is 1 is not a cubical, I mean 1 is not a root of given cubical equation. Now trial and error method, it can be either negative or a positive numbers. It can be either negative or a positive numbers. Okay. So I'll go with a 2. I'll go with a 2. So I need to erase all these things. But initial value will be 0 only. So 1, 2 ones, it's a 2. Minus 6 plus 2, minus 4. 2 minus 4, 2 into minus 4, it's minus 8. It is 4. 2 fours are 8. And C, you got 0 here. Okay, you got a 0. So purely it is a trial and error method. You need to select one root, okay, one number. You imagine that number as a root and follow this procedure. And at the last column, you need to get the 0. The addition of last column should be 0. Then only you can say this is one root. So if you got a 0, so this will be one root of cubical equation. So here I can have k1 is equal to 2. I don't know about K2 as well as a K3. I don't know this one. Now you can consider, you can follow the same procedure. Okay, you can follow the same procedure by considering again some other number and you can follow. Otherwise, the another simple way is, now we got a one root. Now you can convert this into a quadratic equation. Okay, a quadratic equation, how it is? So this becomes x square minus 4x and plus 4 is equal to 0. So this is a quadratic equation. Now we need to find the roots of this quadratic equation. So this method is called as a synthetic division method. Hope you understood right now, right? Yes. So I'm erasing this one. Synthetic division. So if you know any other method, no problem. You can follow that and you have to find the roots. That's it. Now, after finding one root, the quadratic equation is x square minus 4x plus 4 equal to 0. So we can apply the formula directly, minus b plus or minus square root of b square, or else I'll convert this into x square minus 2x plus 4 equal to 0. So after adding this one, we will be getting minus 4, and if you multiply this one, we will be getting 4x square plus 4x square. So here take x as a common, x minus 2, and minus 2 as common, and x minus 2 is equal to 0. So x is equal to 2 and x is equal to 2. So obviously the two roots are k2 is equal to 2 and k3 is equal to 2. Okay, now you had three roots and now we need to apply any one of the cases. We have seen different cases. Okay, case 1, case 2, case 3. Case 1 means roots are distinct, all roots are different. And case 2 is roots are equal. Okay, so all the three roots are equal. And the third case is roots are real and imaginary. Now, this is here k1, k2, k3, all the three roots are equal. So in this case, we have to apply the second case formula. So I'm erasing this one. Hope you understood this, how you can get the equation. So I'll write it here. If you are having any confusion, you can refer this one. Okay. So I'm taking x as common, x minus 2 and x minus 2 equal to 0. So x equal to 2 and x equal to 2. So obviously it will be k1, k2, k3. All these are the different roots, right? So if all are equal, so here we can say roots are equal. So if roots are equal, what we have to apply? So the general solution an is equal to, so a plus b into n plus c into n square into k power n. So this is the general solution. Okay. So this is the general solution if all the roots are equal. Now you can apply, right? An is equal to a plus b into n plus c into n square. What is the k value? 2 power n. Okay. Now we need to avoid the constants. So here we got some initial values. Okay. If there is no initial values, this will be the solution. Okay, obviously this will be the solution if there is no values. But here we have given some initial values, a0, a1 and a4. Consider a0 is equal to 1. So replace n is equal to 0. a0 is equal to a plus b into 0 plus c into 0 square whole power, into 2 power 0. So which becomes, here a0 value is 1. 1 is equal to a plus 0 plus 0, a plus 0 plus 0 into 1. So 1 is equal to a. Okay. So obviously we can say it as a is equal to 1. So we had one constant 1. Okay. We had one constant 1. Now what we have to do? We have to apply a1 and a4 also. Okay. So in this a1 and a4, I am erasing this one. Hope you understood this synthetic division method, right? Yes. So I'll use n is equal to 1. a1 is equal to a plus b into 1 plus c into 1 into 2 power 1. That becomes, what's the a1 value? It's a 4. 4 is equal to a value. A value is 1. So 1 plus b plus c into 2. So 4 is equal to 2 plus 2b plus 2c. So 2b plus 2c is equal to 2. Okay. So from this we can say it as b. Okay. So just leave it. Next, n is equal to 2. N is equal to 2. a2 is equal to a plus b into 2 plus c into 4 into 2 power 2. So which becomes a value 1 plus 2b plus 4c into 2 square. That means a 4. a2 value is 28. Okay, a2 value is 28. So here it becomes, so 4 7 is equal to 1 plus 2b plus 4c. So 2b plus 4c is equal to 6. So this is one more equation. So this is one more equation. Okay. So we got our two equations with b and c. So from these two equations, we can find the values of b and c values. Okay. Yes. So 2b plus 2c is equal to 2. 2b plus 4c is equal to 6. So apply the subtraction. So this is cancelled, and minus 2c is equal to minus 4. Okay, so the c is equal to 2. C is equal to 2. Right? Hope you understood. from these two equations we are solving, right? We are subtracting that. We are subtracting one from another. So obviously the b part will be cancelled and this becomes minus 2c and this becomes minus 4. So c becomes 2. Now you can apply in equation 1 or equation 2. So let it be applied in here. 2b plus 2 into c is 4 is equal to 2. So 2b is equal to 2 minus 4 minus 2 and b is equal to minus 1. Okay, now the constants. The constants are a is equal to 1, b is equal to minus 1, c is equal to 2. These are the constants. And also k is equal to 2. All these are the constants we find, right, by solving these equations. Now we know the general solution is this one. So simply apply the constants and a k value in this particular equation. So I will erase this one. Okay, I'll erase this one. So the general solution is an is equal to a means 1 plus b into n. So minus 1 into n plus c 2 into n square into 2 power n. So this is the formula. This is the general solution. An is equal to 1 minus n plus 2n square 2 power n. So this is the general solution for this particular equation, right? So yes. Okay, so hope you understood this one. So in the same way we have to solve any higher order recurrence relation, right? Yes. So let's stop here and hope you enjoyed the session. And if you are having any queries regarding this one, feel free to post your doubts in the comment section. Definitely I'll try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.